All right, so this is the last question of our exam one material. And this question reads, select all of the true statements about electromagnetic radiation. First is UV light has a higher frequency than visible light. Next is the SI unit for wavelength is nanometers, nm. Next, the longer the wavelength means higher energy. Next, higher frequency means higher energy. And next, the speed of light is 12 meters per second. Okay, so we've got 5 answer options. Now, the first thing I'm going to do is I'm immediately going to get rid of this one right here, because the speed of light is 3 times 10 to the 8th meters per second. It's 3, what would that be, 8 zeros? So we're talking about, so 30 million, 300 million, 300 meters per second. So it's much faster than 12. In addition to that, you are given a couple of different constants in your formula chart, your formula sheet, and one of them is 3.0 times 10 to the 8th meters per second. It's the only one that's going to be in meters per second. So speed of light matters, and you'll see that. Anyway, so I'm going to eliminate that. Next up is higher frequency means higher energy. Okay, so one of the things that's important to know about electromagnetic radiation and wavelength and the energy spectrum is you have to know about the relationships between the different types of radiation. I always like to go ahead and label them out as in the sequence that I remember them. Gamma rays, X rays, UV light or UV energy, and then vis, then IR, and after IR is radio. One thing that I always remember is that radio waves are super long. So if I say lambda, this would be longer, or longest. This would be shortest. Now, a relationship that exists between wavelength and frequency is that the shorter the wavelength has the higher frequency. Therefore, the longer the wavelength means that the lower the frequency. So it's number of events per second. So if the wavelength is super short, it's going super fast in 1 second, or it's going to occur many times in 1 second. Now, what that also means is, well, higher frequency is higher energy. I always think about this in terms of things that I can relate it to. For instance, whenever I'm standing next to a radio or my car stereo, I'm not necessarily concerned about a huge amount of energy being exerted because of radio waves. Compare that to going to the doctor for an X-ray. Well, that's shooting energy through my body so that I can detect, bones. At any rate, so those are the relationships that I think are important. I would definitely know this, and then definitely know wavelength and how that relates to frequency and energy. So for this first one, we're starting at the bottom, higher frequency means higher energy. Absolutely true. Longer wavelength means higher energy. Okay, longer wavelength. Well, radio waves are long, and those are very weak. They have low amounts of energy, so that's off the table. So I'm not going to scribble it out. I'm just going to skip over it. I'm also going to erase that. So I'm putting an X by the ones that I think are true. The next one is the SI unit for wavelength is nanometers. It's quite common to see nanometers because we talk about visible light, which is usually referred to in nanometers, but that is incorrect. The correct is meters. Okay, then UV light has a higher frequency than visible light. Okay, so this was where it becomes important for us to know the sequence, which are the shortest, and move to the longest wavelengths. And we can see that UV light or UV electromagnetic radiation precedes visible light. So it's to the left of it. And if we think about our frequency, high frequency versus low frequency. Frequency, we can see that yes, indeed, UV has a higher frequency than visible light. So I'm going to mark that one as true as well. Okay, so that sums up all the questions for exam number, or the material that corresponds to exam number 1. I hope this was helpful, and I'll see you when we talk about exam 2 material. Have a good one.